Speculative decoding in a nutshell. Speculative decoding is a technique that reduces inference time for LLMs at the cost of increased concurrency and compute, while guaranteeing the same accuracy. In many use cases, compute is not the bottleneck, so it can be traded for another pillar of performance, speed. How does it work? It works by using two language models, a small one and a large one. And then once a large model has finished generating, depending on whether the small model matches the large model, the output gets kept or not. But let's look at it with a visual example. Our model of choice creates tokens, one after the other, and is finished after a certain amount of time, which might be fast enough for our purpose or not. Let's see how this is done with speculative decoding. Again, we have the big model and the small model. The small model has the first token first. It then goes to the next step. Once the big model has finished with the first token, we check whether it matches. It matches, so both is an A. Then we continue. We have the next token from the small model. We go to the next step. We get the result from the big model, from the previous one. We again check, yes, it's a match, so we can continue. With the next token, now the large model has something else. So we keep the one from the larger one, and we have now, if we compare this, we have now saved some time compared to if we would just run the big model. So how is speculative decoding compared to beam search and greedy search? Well, speculative decoding has inference time as an improvement objective, which is different from what the other approach is going for. Beam search optimizes for accuracy and not for inference time. Greedy search might improve inference time, but does so at the cost of accuracy, which is not affected with speculative decoding. However, we could probably compare these two approaches with speculative execution, as there is no sampling necessary for greedy search, as there is only one total proposal per step.